In this video, we're going to be going over a minimum spanning tree. It's a type of graph algorithm. So let's say that our goal is to take this example graph and link the nodes together as cheaply as possible. So all of the weights of the connections add up to the smallest possible value. So one example of linking the nodes together as cheaply as possible would be here. So here every node is connected and in a minimum way. So there's no nodes that are connected unnecessarily in order to keep all the nodes connected at least by one edge. Here's another example of linking together all the nodes in some way. So every node links up to one another. Another option is here. All the nodes are linked. You can travel from any one node to any other node. So 3 different options here of how to link together the nodes as cheaply as possible. This is called a spanning tree, and a spanning tree in an undirected graph is a set of edges with no cycles that connects all the nodes. So all 3 of these are spanning trees. So now let's look at the cost of those 3 spanning trees that we just came up with. So the cost of this spanning tree is 50. So we're just taking and adding 3, 6, 5, 7, 8, 12, and 9. When you add those up, you get 50. The cost of the second spanning tree that we came up with is 49. So we're adding 3, 4, 7, 8, 6, 12, and 9 together. And when you do that, you get 49. And then the last one adds up to 22. So we get that by adding 1, 3, 5, 4, 1, 6, and 2 together. So as you can see, out of the 3 spanning trees that we came up with, this one would be considered the minimum spanning tree because they're linked together in the cheapest way possible. So a minimum spanning tree is just a spanning tree with the least total cost. So note that we did talk about spanning trees when we talked about Dijkstra's, and the important thing to note is that the shortest path tree that we used for a spanning tree is not necessarily an MST. Sorry, I have to sneeze. But the reverse is also true. So an MST may not be the shortest path tree, and the shortest path tree may not be an MST, just as a side note, but it is a spanning tree. So MSTs have lots of interesting applications. At the end of the semester, during week 15, we're going to have all of these different researchers and people in industry talk about different applications of data structures that they've worked on or that they're interested in. And some of them are actually involving minimum spanning trees. So a couple of the most common ones, and I'll talk about it in 2 videos from now, connecting any sort of grid system, electric grid system, or any sort of networking system, or any sort of telecommunication system is a minimum spanning tree problem typically. And it's actually the initial motivation for studying minimum spanning trees by Otakar Borufka in the early 1920s. There's also data clustering, maze generation, computational biology, and I'll talk about some of those in a future video. Common MST algorithms include the original algorithm, Borufka's algorithm, as well as Prim's algorithm and Kruskal's algorithm. We're going to focus on Kruskal's algorithm which is the algorithm that can find a minimum spanning tree in this class, but there's a couple. So that's it for this video.